This is 8-2, characteristics of quadratic functions. So far we can look at an equation and know that it's a quadratic function if it has a degree of 2. We also know that a table of values is quadratic if the second degree is constant. We know that if parabolas open up or down based on the a value, if it's up, the a was positive. If it's going to open down, the a was negative. We know about max and min. We can find the domain and the range. And so now we're going to focus on some characteristics of quadratic functions. The first thing you're going to need to be able to do is to find the zeros of a graph. So in order to find the zeros of each quadratic function from its graph, you have to know what a zero is. A zero is where the parabola intersects with the x-axis. So in this parabola, there happens to be two zeros. One of them is at -1 and the other is at 2. So our zeros are at -1 and 2 would be our answer. Okay, for example B, there's my zero where it's hitting the x-axis. That's at 1, so my answer would be 1. At C, it's not hitting the x-axis anywhere. It's up above. It's nowhere on the x-axis, which is right here. And so therefore, I can't put 0 because that would mean that I'm hitting at 0, this dot that I'm making right here, and I'm not hitting at 0. So I can't put 0. I'm going to write that there are no zeros. So when we're asking to find how many zeros, we could only say that they either have 2 zeros possible, 1 zero, or no zeros. That's our possible answers for if it says how many. If it asks specifically for what the zeros are, you have to look at where it's hitting the x-axis. I want you to try these, and I'll give you the answer. So pause the video when you're ready, and then I'll give you the answer. Number 1, the zeros of number 1, it's not hitting anywhere on the x-axis. So number 1 would have no zeros. Remember that you cannot put the 0 as a number. You have to write no zeros. Number 2 is hitting at 3, where x is 3, and so I'm just going to put 3. There are a couple ways to find the axis of symmetry. One of the ways you can find the axis of symmetry is by averaging the zeros. Let me first tell you that the axis of symmetry is where if you folded up this parabola in half, they would make a crease or a line. And so if we took that red parabola and folded it in half, there'd be a crease right here along this axis of symmetry. An axis of symmetry is a line, so we have to write it as an equation of a line. Any undefined slope or vertical line like this is going to have an equation that looks like x equals and the number. X equals 2 in this case because I was crossing through the 2. Now if you don't write that x equals 2, I'm just going to erase this so you can see that x was going through the 2. If you don't write the x equals and you just write 2, you're incorrect because this is a line. The axis of symmetry is a full line and you have to have x equals 2. The reason why people end up with a C on the upcoming test is usually because of axis of symmetry. You have to write that as an equation. Okay, and so for the next one, I can see my axis of symmetry on this one as well without doing any math. It's going to be at x equals 3. But if I was unsure, if it's hard to tell that, there is another way to do this. You can calculate this using our zeros, so the average of the zeros. Well, in the first one, the zero is very obvious. It's just x equals 2. But on the bottom one, I have a 0 of 1 and 5. And so I can average them. We all know how to take an average, I'm sure. So we're going to add these numbers, 1 plus 5, we get 6. And then we divide by how many numbers there are. So we take the total and we divide by 2. So the total is 6 divided by 2, which is 3. And then I write my equation as x equals 3. Again, here's an example, a couple examples. So just pause the video and then I'll give you the answers. Okay, for the 2A, the axis of symmetry is going to be right at that vertex. Since there's only one point, I could draw the line down, and I can see that's going to be at -3. So x equals -3. For 2B, it's a little bit harder to tell exactly where it's going to be. It looks like it's going to be right around here, but I'm going to double check that it's x equals 1. So I'm going to write my zeros, -2 plus 4. Those were my zeros. That's the total divided by 2 to find the average. So I'm going to add those, -2 plus 4. You can put that in your calculator if you want, but that's 2 divided by 2, which is 1. So I was correct. So x is going to equal 1. That does make sense. If you didn't even know where to begin, you just average them. Just double check that that makes sense in the picture. If you get a line that's over here, like an x equals 3, or 4, sorry, x equals 4 equation, you know you made a mistake. There's no way that the axis of symmetry could be all the way over there. It's got to be near the middle. You can also find an axis of symmetry using a formula. The formula is x equals -b over 2a. It's written right here, x equals -b over 2a. What does all that mean? Well, you have to be given the equation. Okay, so in the equation, y equals 2x squared plus 4x plus 5. Let me get my pointer out. It's ax squared plus bx plus c. If you ignore the y equals, we looked at this in chapter 7 when we were factoring trinomials. We did the a times c and all that stuff. So we already know these letters are a, b, and c. So I'm going to set up my formula, -b over 2a. The b comes from this 4 right here, so it'd be -4 over 2 times whatever a was. Well, a is right here, which is 2. So that's written right here for us, -4 over 2 times 2. Well, 2 times 2 is 4, and 4 divided by 4 is 1 with the negative in front. So it comes out as x equals -1. So here's one. We've got y equals x squared plus 3x plus 4. We're given the equation. When we're given the equation, I want to use this formula. Otherwise, I'd have to graph it, and it would take a long time. Oops. That negative can either be there, or you can have the negative right in front of the b. Right in front of the whole fraction, like this. Whatever's easier for you. I usually have it up top. I just like to do it that way. So -b. Well, I know that my a is 1. That comes from right here in front of x squared. There was no number, so it's a 1. And my b is 3. That's coming from right here in the middle. And so if I do -b, I'd get -3 over 2 times 1. Well, -3 over 2 is, 2 times 1 is 2, so it's just going to be -3 over 2. So x equals -3 over 2 would be my final answer for that. That is going to be my axis of symmetry. Remember, that's where the line would be down the parabola. So if I have my parabola, and I draw the line down for the axis of symmetry, this would happen at -3 over 2, or -1.5. Try this example, and then pause the video. When you're ready, I'll share this answer for you. So I start with my formula since I was given the equation, x equals -b over 2a. I know that my a is 2 and my b is 1. There was no number in front of x, so that's going to be 1, and my 2 came from right here. And I'm going to plug into my formula. X equals -b, well, that'd be -1 over 2 times whatever the a was. Well, a was 2. And so I end up with x equals -1 over 2 times 2 is 4. So -1/4. It's a simplified fraction, so I can leave it that way. We are going to find the vertex of the parabola. These are really good steps. If you want to take a minute and copy down these steps before we get started, just pause the video. So following these steps, if we're going to find the vertex, first we have to find the axis of symmetry by using our equation. So I'm going to do x equals -b over 2a. A is -1, b is -2. And so x equals -b, which is -2, over 2 times -1. Just know that this -2 is a +2. So you get 2 over -2. Well, that simplifies. 2 divided by 2 is 1, and so x equals -1. And this makes sense. If you look at the axis of symmetry, x is at -1. In order to have the vertex, we're not done, though. Next, we need to know the y-coordinate. So we're going to plug in in order to get our ordered pair of a vertex, we're going to plug in the x equals -1 into the original equation. So y equals negative, I'm going to put -1 here, squared minus 2 times -1, because the equation was y equals -x minus 2x, and so I've replaced the x. Now I calculate, I'm going to follow PEMDAS, so exponents first. -1 squared is 1, times the negative is -1. -2 times -1 is +2. So y equals -1 plus 2 is 1. So that goes in the y spot. Now I have my ordered pair, and that's our final answer for the vertex. Okay, in order to find the vertex given the equation, remember a vertex is an ordered pair, they tell us to start with the x, which comes from the axis of symmetry formula, -b over 2a. In this equation, a is 1, b is -4. So if we have a negative b, that b is going to become +4. -4 is +4 over 2a, 2 times 1. So 4 over 2, 4 divided by 2 is 2. So my axis of symmetry is x equals 2. As an ordered pair, that is half of my ordered pair, 2 comma, that's horrible, 2 comma something. In order to find that y, I take my x equals 2, and I plug it back into the x spots of the equation. So I get y equals 2 squared minus 4 times 2 minus 10. We replace variables with parentheses, remember. So 2 squared is 4 minus 8 minus 10. 4 minus 8 is -4, minus 10 is -14. So my vertex is 2 comma -14.